type problem. So, farmer making a pen out of 480 yards of fencing. It's going to be a rectangular pen. So it's going to be a pen that looks something of this nature. Whoop. Do it every time. He's going to divide the pen into 3 sections that will all be the same area, and they are all going to be rectangles. I left out the rectangle requirement in the problem. I know my drawing isn't to scale, but you can forgive me. You know I'm not an art teacher. The farmer is making pen out of 480 yards. He wants to maximize the area. What we do is we look at the phrase that's going to drive the problem, and maximize the area is what drives the problem. So I like to divide my work up into 4 boxes. You guys have learned that. If you want to follow through, you sure can. I like to model the problem here, and I like to write the formulas and the relationships over here. What is the formula for area of this problem? Area is, for a rectangle, base times height. I'm going to use length times width in this situation. As long as you have 2 variables, that's fine. And if you notice here, I have length here, and I have width here. And if I would like to maximize the area, okay, I need a formula that just has 1 variable and not 2. I need to get rid of one of these. And so hopefully you remember this type of work from last year, but I'm going to label this as L, W, W, and W. Can somebody give me another equation that involves L and W in this situation? For W plus 2L now that I have a second equation, I can combine those together to make 1 equation. So I would like to solve either for L equals or W equals. I would prefer the L equals personally. So 2L is equal to 480 minus 4W. Divide by 2, L is 240 minus 2W. Is everybody good there? So here we have it. If I take this and I plug it in right there, I get area is width times 240 minus 2W. Or rather, area in terms of W is the variable that I'm choosing to use, is 240W minus 2W squared. Now, at this point, let's lean in a little bit and let's understand the calculus behind this, because this is where it really kind of gets cool. Everything now you've seen before. We've done this before. So what's new about it? The approach to solving it is what's new. Calculus gives us amazing insight that we didn't have before. What shape does that make if we were to graph it? Right side up or upside down? Upside down, right? Okay. Does it have a maximum or a minimum? It has a maximum. Okay? Understand what is true about the maximum. What is 0? The slope is 0. The derivative is 0 at the maximum. Isn't that great? Now, it used to be in this situation, you're like, I would like to find the vertex of the parabola. So I would do something like negative b divided by 2a. Do you remember that? And that would help us to be able to find the maximum. Well, now we say we don't really need to do this fancy stuff of negative b divided by 2a. Let's just take the derivative. What's the derivative of 240w minus 2w squared? And we're going to set that equal to 0. We're wondering, when is the slope 0? We solved it. We had 240 is equal to 4w, or 60 is equal to w. The question was, what dimension should he make the pen to maximize the area? Well, if the width is 60, how do I figure out what the length would be? Plug it back in. This tells me the length is 240 minus 2w. So 240 minus 120 is 120. So he's going to make the pen 60 by 120, and that will maximize the area. Do you agree that for his use, he'd like to maximize the area? Yeah, that's something that's important to him. I want to just show you something cool. I've shown you this once before. I want to bring it back to you just one more time. Ax squared plus bx plus c. Everybody agree that that's the form for a parabola? Let's take the derivative and set it equal to 0. What's the derivative of ax squared? 2ax. What's the derivative of bx? B. What's the derivative of c? Nothing. So we set that equal to 0. Let's solve for x. So we get 2ax is equal to negative b. Let us divide by 2a. X is equal to negative b divided by 2a. Calculus has proved that the vertex of the parabola is in fact at negative b divided by 2a. Let's try setting up a couple others. In fact, I want you to try this one on your own. See if you can work through it. Go ahead. Difference is he sets it up against the barn, so he doesn't need any fencing against the barn. You try. Go. From, not to form. So open box top is to be constructed from a rectangular piece of cardboard with dimensions 10 by 18. So I have this guy right here that measures 10 by 18. And I'm going to cut a square from each corner. Okay with the x by x? It says find the largest volume that the box can have. What's driving the problem? What is our goal? Maximize the. So therefore, that's the formula I write down. What's the formula for a volume of this kind of shape? Yeah, base times width times height, or length times width times height. So I have 3 different variables. That's the problem. If you took the derivative right now, that would be an issue with 3 different variables, wouldn't it? Wouldn't it be nice to have 1 variable? So length, width, height. Somebody, I have this length. The length of the box is it can be 18, more than 18, or less than 18. How much? 18 minus 2x. Width? I don't know. I'm just going to try to ignore it. Okay, and then what would the height be? Height is x. So I take these and I write volume is equal to 18 minus 2x times 10 minus 2x times x. I like to write it as a polynomial. Why? Because it's easy to take derivatives of polynomials. The volume in terms of x is, let's multiply this out. 18 times 10, 180 times x, 180x. Let's do the middles. Negative 2x times 10, negative 2x times 18. What am I going to have in the middle? Negative 56x multiplied by x is negative 56x squared. Negative 2x times negative 2x. 4x squared times x. 4x cubed. So that's my polynomial. Easy to take the derivative of that, correct? What shape does that make? Yeah, squiggle. Very good. Yep. Yep. Hold on. Look at your shape and be smarter than the problem. When I take the derivative and set it equal to 0, how many solutions should I have? Why? Yeah, you see 2 of them. Which one will I want? Will I want the first one or the second one? Why? Maximum. You see that? You're trying to confirm the calculus. What's the derivative? Somebody. Yep, okay, 12x squared. Good. Minus 112x plus equals 0. Somebody have the quadratic formula in their calculator? Looks like that would be really helpful right now, wouldn't it? Yeah. Let's see if we have that. $12, 112, and 180. What do you got? Negative 112, excuse me. 7.27 and what? 2.06. Okay, so which one do we want? Or do we want them both? We're arguing 2.06, and then this would be 7.27, right? These are x values. So you want the 2.06. Think about it, folks. If you plugged it back in, could you cut off 7.27 from each side? No. You'd be cutting off more than 14. You've only got 10 to work with. Can you cut off 2.06 from both sides? Yeah. I wonder what the question is asking. Is it asking what size square should be cut off? No, we know it's 2.06 by 2.06 because that's what x is. It says find the largest volume. I wish that there was an expression up here that told us what volume is. So what do we do to find the volume? Plug 2.06 into that guy, right? Which is the same as plugging in here, multiplying them all together. Can somebody please, actually, I will do it. I've got my calculator right here. I go ahead, I've got 12 times 2.06, and I cube that. Then what is it, minus 56? Times 2.06 squared plus 180 times 2.06. Whoop, second entry, I bring back the whole thing and just adjust this last part. And 301.28. Well, it's this answer divided by. That's really bad. Okay, one more time, second entry. And we're just going to get rid of answer divided by. Don't know how that got there. Delete, delete, enter. Is that better? $12. No, we don't have 12. We've got what? We got 4. 2.06 to the third minus 56 times 2.06 squared plus 180 times 2.06. Do I have it right now? 168.13. What's our measurement in? Does it give us a measurement? Does it give us inches or centimeters? So it's inches cubed because it's volume, right? That's maximum volume. Okay, it's time for you guys to kind of direct the work here because I've been kind of leading things. Let's see if you can reference what we've done in the past and try to work this out. It says dimensions that give the largest area of a rectangle whose base is on the x-axis and whose corners are on the parabola, 12 minus 3x squared. So, yep, very good. I draw it. There we go. Good. We got corners here. Excellent. Now what? Okay. What's driving the problem? Area. Formula for area. Yep. I'm going to call it base times height in this situation. You're going to see why. I'm going to give you just a little hint. We're going to call this coordinate there xy. Does everybody agree I go over x units here? And over x units here, just negative x. So I can't have base and height. I need to get rid of those variables and put something else in its place. What's an expression that involves x for base? Base is 2x. Is everybody convinced by that? What's an expression for height? Exactly. However, that still gives me two variables. I wish that we could replace y with something that involved x. Y is 12 minus 3x squared. So the height is 12 minus 3x squared. So therefore, the area is the base, which is 2x, times 12 minus 3x squared. (24x minus 6x cubed). The derivative, do you know what that shape looks like? Yeah, it goes like this because it's negative, right? So are we going to want the first one or the second one? You're going to want the second one. What's the derivative? Minus. Set that equal to 0. For 24 is equal to 18x squared. 24 over 18. 4 over 3 is equal to x squared, so we square root. 2 roots of 3 over 3. We'll get a decimal here as well. 4 divided by 3, 1.15. Plus or minus. Which one do we want? The positive one. So what's the question asked? Dimensions. So what is the base? If x is 1.15, what's the base? The base says it's twice the x value. The x value is 1.15, so 2.3. How would we determine the height? Plug in x for what? Yeah, 12 minus 3x squared. So I go ahead, 12 minus 3 times 2.06, whoops, sorry, 1.15 squared. And I get 8.03.